symbol comes from the Latin root of the word nature.
Okay, so for this question, we will be breaking down this equation, NH4CO2NH2. So the elements found are N, H, C, and O, which stands for nitrogen, hydrogen, carbon, and oxygen. Using a periodic table, you can find how many atoms all of these elements have on their own. So nitrogen has 2, hydrogen has 6, carbon has 1, and oxygen has 2. And at the end, you add all of these together, and you get a final number of 11.
Exercise 3b, and I'm going to be balancing this equation. So, first we're going to look at each element separately. We can see that these two are already equal on both sides, but nitrogen is not. So we're going to want to add 1 here. Since nitrogen is up here, we're going to want to multiply it by 2. So this is going to become 2. Here will be equal. But this also affects oxygen. So now oxygen will become 2 times 2, so 4 plus 2 plus 1. So that makes 7. But since we want oxygen to be equal with the other side, we're going to need to make this an even number. So we're going to put a 2 over here, and that's going to make 2 plus 4 plus 2 makes 8. Except this affected that 2, so now we have 2 there, but we only have 1 here. So we're going to have to multiply this one by 2, but that 2 is going to affect nitrogen and oxygen, so we're going to multiply by 2 everywhere. So now we have 2 here, 4 here, and 12. So 2 and 2, those are equal. Nitrogen, we have 4 here and 2 here, so we're going to have to multiply this by 2 again. So we're going to put 4 instead. So now this will become 4. And now the last one is oxygen, but we're no longer at 8. Since we changed that to 4, we're at 2 plus 8 plus 2, and that makes 12. So we're all good. That's perfect. And our final equation is 2, 2, and 4. That makes about...
Today we'll be looking at how to calculate moles. So here we have a handy-dandy triangle that basically gives you the formula to find all 3 of these things. So today we're going to be finding the number of moles. So we're going to hide it, and we're going to find the mass divided by the relative mass. So then here we have an example. We already know the mass. We have 51 grams of aluminum oxide. So AlO3 is the formula. So now we have to find the relative mass. So for Al, we have 2 of them, and we know that it's 27 for 1 of them. So we do 2 times 27. And for oxygen, we know we have 3 of them, and we know that 1 oxygen is 16. So we do this whole calculation, and it all totals out to 102. So then we go back to this formula, which is mass divided by relative mass. And so the final thing is 51 divided by 102, and of course it's in grams, equals 0.5 moles. Thank you.
Okay, so now we're going to be calculating relative molecule mass. So first we're going to use this formula here, this equation. First thing to do is separate each element. So first we have carbon, we have hydrogen, and we have oxygen. Then we have to see how much of each we have. Carbon we have 2, hydrogen 6, and oxygen, we have 1. There, we're going to multiply that amount by the element's atomic mass. which we can find in the periodic table. So for carbon, it's 12. For hydrogen, it's 1. And for oxygen, it's 16. This makes 24, 6, and 16. We're going to add all of these together, and that's going to make 46 MR. There you go.